outcome label or target variable. అంటే ఏంటి అంటే, so if you take sunny, then outcome variable yes, అట్లాగే sunny, then outcome variable no. So this is your attribute and this is your outcome value. So for these two we have calculated the probability. Okay, so example ఏంటి అని అంటే, lightning occurs and thunder comes. So that is nothing. Thunder is dependent on lightning. So these two are conditionally dependent variable. So ఇంతకుముందు చూసింది మనము అవి independent of itself. If you see, for dependent variable, one is dependent on another. One particular variable is dependent on other variable. The student is dependent on teacher. Teacher is independent of itself. He is not dependent on others. Okay, so this is the difference between conditionally independent and conditional dependent. Okay, so this is the difference between conditional dependent and conditional independent. So but in Navy base we assumed all the variables as conditional independent. Navy base lo anni conditional independent అని తీసుకొని మనం calculate చేసినాం. But in case of Bayesian belief networks, allow stating conditional independence assumptions that apply to subset of the variables. మనం ఏం చేస్తున్నాం ఇక్కడ, Bayesian belief networks we can state conditional independence. అంటే ఏంటి అని అంటే, some variables in training set are conditional independence, but some variables are conditionally dependent. కొన్ని independent, కొన్ని not independent. Okay, so the difference between Navy based classifier and Bayesian belief is nothing but, Navy based law each and every attribute is conditional independent itself. But in case of Bayesian belief networks, whatever the attributes which are there, some attributes, subset of attributes are independent of itself and subset of variables are dependent on itself. Konni atla, konni itla. Okay, so in that way we'll assume it in Bayesian belief networks. So one variable has dependence on other. If one variable is occurring, it increases the probability of other variable occurring also. So what we are doing, probability of one variable, it increases or decreases the probability of the other variable. So this is called as conditionally dependent. Okay, so in Bayesian belief networks we need not apply this condition entirely. We can apply it for some subset of variables. We can assume this condition for some subset of variables. There are conditionally dependent అని మనం కొన్ని వేరియబుల్స్ కి అజ్యూమ్ చేసుకోవచ్చు, కానీ అక్కడ అన్నిటికీ ఇండిపెండెంట్ అనే అజ్యూమ్ చేసుకోవాలి నేవీ బేస్ లో. ఓకే, సో దిస్ ఇస్ ద డిఫరెన్స్ బిట్వీన్ దీస్ టూ. సో why we use set of variables are conditionally dependent or independent, ఎందుకు తీసుకుంటున్నాం మనం? Okay, so here in some cases there are some parameters which cannot be measurable. That's why we are taking some variables as conditionally independent and some variables as conditionally dependent. When we cannot measure the attribute values or the parameters of the parameters data, then we will be using those from that data we will take some as dependent and some as independent. Okay, so that's why we consider some variables as independent variables. We will be giving the condition on some data with independent and some data with dependent in Bayesian belief networks. So it is an intermediate approach that is less constraining than the global assumption of conditional independence made by the Navy-based classifier, but more tractable than avoiding conditional independence assumptions together. So in general, a Bayesian belief network describes the probability distribution over a set of variables. So if we have multiple variables, what is the probability distribution between them? So that some of them happen together and some of them are independent together. That we have to see here how we describe it. Okay, so it will describe in that way, that is by using Bayesian belief networks. So now consider an arbitrary set of random variables y1 so on to yn, where each variable yi can take on the set of possible values v of yi. So what we are doing, we are considering some random variables. What are those? Y1 so on yn, where each variable yi can take set of possible values v of yi. అంటే ఏంటి అని అంటే ఎగ్జాంపుల్ లైక్ స్కై ఎట్లుంది, స్కై ఇస్ సన్నీ, క్లౌడీ, నార్మల్. ఇది attribute value. These are outcome values for that particular attribute. Humidity, this is one more attribute. Attribute ఎట్లా ఉంటాయి, దాని వాల్యూస్ అవుట్కమ్ వాల్యూస్ లో, మీడియం, హై. ఓకే, ఇంకోటి తీసుకోండి attribute, that is outlook. Outlook ది గుడ్, బ్యాడ్. Okay, so what we are doing, set of attribute values indicated by v of yi. v అంటే ఏంటి, మీ అవుట్కమ్ వాల్యూ. అవుట్కమ్ వాల్యూస్ అంటే ఇవి అవుట్కమ్ వాల్యూస్. yi అంటే మీ అట్రిబ్యూట్ వాల్యూ. ఈ అట్రిబ్యూట్ వాల్యూకి ఏమి అవుట్కమ్ వాల్యూస్ ఉన్నాయి, సో దట్ ఈస్ డినోటెడ్ బై v of yi. ఓకే, we define the joint space of the set of variables y be the cross product of this. Okay, joint space and ఏంటి, so here you can see joint space. So what is joint space? How many values allowed for sky? ఇంతకుముందు స్కై తీసుకున్నాము, దానికి ఎన్ని వాల్యూస్ ఉండే, 3 వాల్యూస్. ఏంటి అవి, సన్నీ, క్లౌడీ, నార్మల్. ఎన్ని ఉన్నాయి ఇవి అవుట్కమ్స్, 3. అట్లాగే ఇంకోటి ఏం తీసుకున్నాం, హ్యూమిడిటీ. హ్యూమిడిటీకి ఎన్ని ఉండే, 3. ఏంటి అవి, లో, మీడియం, హై, దట్ ఈస్ ఈక్వల్ టు 3. ఓకే, నెక్స్ట్ అవుట్లుక్. అవుట్లుక్ కి గుడ్, బ్యాడ్, దట్ ఈస్ ఈక్వల్ టు 2. Okay, so that is 3 into 3 into 2, that is equal to, you will get 18 combinations. 18 combinations in joint space of set of variables y. ఇవేంటి వేరియబుల్స్, ఇవి ఈ y వేరియబుల్స్ కి ఎన్ని కాంబినేషన్స్ వస్తాయి, 18 కాంబినేషన్స్ వస్తాయి మీకు, ఒక్కొక్క ఇన్స్టాన్స్ ఒక్కొక్క అట్రిబ్యూట్ తోటి. Okay, so that is called as joint space. So what we are doing, we have to define the joint space here of the set of variables y to be cross product of this, and v of this into v of this into v of this is equal to those combinations we will get. That is called as joint space. Okay, so now the probability distribution over this joint space is called a joint probability distribution. Now if we assign a probability distribution to this particular joint space of 18 combinations, then it is called as joint probability distribution. Okay, the joint probability distribution specifies the probability for each of the possible variables bindings for the tuple this. So what is the probability of this combination of attributes, combination of attributes? అంటే ఏంటి అంటే ఎగ్జాంపుల్ ఏంటంటే వాట్ ఈస్ ద ప్రాబిలిటీ ఆఫ్ సెట్ ఆఫ్ క్లైమేటిక్ కండిషన్స్ ఆన్ ఏ పర్టికులర్ డే అనేది నా క్వశ్చన్. ఓకే, సో ఏంటి ఇక్కడ ప్రాబిలిటీ ఇస్ అసైన్డ్ టు ఆల్ ద పాసిబుల్ కాంబినేషన్స్. క్లైమేటిక్ కండిషన్స్ ఎట్లా ఉండాలి? ఇఫ్ ఐ వాంట్ టు ప్లే టెన్నిస్, what are the set of climatic conditions I have to consider here? It should not be cloudy. Okay, humidity should be somewhat medium or high. Outlook should be good. So likewise. So what I am doing here, I am using all these probabilities. Okay, so probability is assigned to all these possible combinations. Then I'll get some outcome. So here what I am doing, on some set of variables I am using independent condition, and on some set of variables I am using dependent condition. So let us understand the idea of conditional independence. So we say that x is conditionally independent of y given z if the probability distribution governing x is independent of the value of y given a value for z, that is if. So we say that x is conditionally independent of y given z. So till now we have seen em chusna manam probability of x given y em chusna manam ante x given y annattu. So the variables are independent of itself. So x is not dependent on y when given on z. That is nothing but if z is given, which may have some conditional independence on x, but y will not have any dependence. So that is x is conditionally independent of y given z. So here z is given. Z is given and which may have some conditional dependence on x, but y is not any dependence on x. Okay, so that we are specifying. Ante enti konni dependent, konni independent. So that we are specifying here by using Navy-Bayes concept in Bayesian belief. So x is conditionally independent of y when z is given on z. So this condition we are applying here. If for every xi, yj, zk, ante enti ante variable values ivanni xi, yj and zk anedi variable values, that is equal to, so this is the condition enti kada, probability x having value xi ante sky is equal to sunny ani, y is equal to yj ante humidity is equal to some high ani, z equal to zk ante outlook is equal to good ani. So itla conditions unnai మన దగ్గర. So x having value xi is conditionally independent. So this is x value is conditionally independent on y having value yj which is given z equal to zk. ఇక్కడ ఏమవుతుంది, x is conditionally independent of y given z. అంటే y అనేది ఇండిపెండెంట్ ఇక్కడ వేరియబుల్. ఓకే, సో y is independent కాబట్టి we are eliminating that and we are considering these two together. So x have some conditional independent from y, so we eliminate it. Then we will get this value. If xi belongs to v of x, yj is equal to vy, zk belongs to vz. So we commonly write the above expression in abbreviated form as this. Wait a minute, guys. So the definition of conditional independence, can be extended to set of variables as well. We say that the set of variables x1, this is conditional independent set of variables this, given the set of variables this. And any set of variables this is conditionally independent on the variables this, given the set of variables of this. అంటే ఏంటి ఇక్కడ, ఇవి ఇండిపెండెంట్ అని, ఇవి రెండు డిపెండెంట్ అని. So that we are specifying here if this is the case. So x is conditionally independent of y given z. So instead of x, we assume set of variables x1 so on x3. Okay, instead of y, we are assuming y1 so on yn. అంటే ఇక్కడ ఏంటి, ఇండివిజువల్ గా కాకుండా ఇప్పుడు సెట్ ఆఫ్ వేరియబుల్స్ ని తీసుకుంటున్నాం మనం. ఓకే, సో వీఆర్ అప్లైయింగ్ కండిషనల్ ఇండిపెండెన్స్ నౌ. ఓకే, సో వెన్ this particular variable is conditionally independent on this particular variable given the set of variables this, so if probability is this, that is equal to probability of x so on xl tends to z1 so on zn. అంటే ఏంటి, ఇవి రెండు డిపెండెంట్, ఇది ఇండిపెండెంట్ అని. సో దాట్స్ వై వీఆర్ ఎలిమినేటింగ్ y value from this formula, from this representation. So in Navy-based classifier, we have used posterior probability of H given training examples, that is probability of H by D. So this we have seen. And ఏంటంటే hypothesis to become true, to be more probable, it depends on training example. So if we give good set of training examples, which is not biased, then what will happen? It easily prove that hypothesis will be true and it is more probable. So that is case of naive-Bayes classifier. So now what we are doing? Here we are assuming probability of x comma x comma y comma sorry x given y comma z. So this we are using here. Okay, so there is relation between this definition and our use of conditional independence in the definition of naive-Bayes classifier. So this is the difference or relation in between naive-Bayes classifier and Bayesian belief networks. Naive-Bayes classifier, we will be using the conditional independence, but the total conditional independence. But in case of Bayesian belief networks, we will be using both. For set variables, we will use conditional independence. For set of variables, we will use conditional dependence. Okay. So in naive-Bayes classifier, if you take example, I'll tell you, sky is conditionally independent of some instance attribute, that is humidity. Given target variable, playing tennis. On that particular day, if it is yes. So మన ఏం చేసినాం naive Bayes classifier లో conditional independent యూజ్ చేసినాం. Okay, one attribute is independent of itself. Sky condition ఇచ్చినాము, humidity condition ఇచ్చినాము, whether we can play tennis or not. How will be the outcome on that particular day, if it is yes or no. Okay. So here it allows probability of so here in Bayesian belief networks, how Bayesian belief networks are represented. Why we call them belief networks? Why we call belief networks? Because if two variables x determine x determine x, x determine so x determine sorry, y, x determine y, or y is independent on x, that means x value y is independent on x means the probability of y is dependent on probability of x. అంటే ఏంటి కదా, probability of y is dependent on probability of x. Probability of example ఏంటి అని అంటే probability of you coming into this world increased because your parents already existing in this world. అంటే ఏంటి అని అంటే the belief అంటే the probability of your parents existing will determine the probability of child existing. So what is happening here? It is providing some belief, it is providing some confidence. ఇది ఉంది అంటే ఇది అవుతుంది, అది అవుతుంది అని అంటే ఇది కూడా అవుతుంది. సో లైక్ వైజ్ వీఆర్ గెటింగ్ సమ్ కాన్ఫిడెన్స్ if two variables are there, x and y. Okay, so here y is dependent on the probability of y is dependent on the probability of x. So this concept we are using in Bayesian belief networks. Okay, so the remaining part we will see tomorrow. I don't know whether you have understood or not. So the difference between Naive-Bayes classifier and the Bayesian belief network is nothing but, in Naive-Bayes classifier we will be using conditional independent, but in case of Bayesian belief networks we will be using set of variables as conditional independent and a set of variables as conditional dependent. So this concept is used in Bayesian belief networks. So with example I will show you tomorrow or day after tomorrow. Sandeep, are you there? Sandeep,
Yes, ma'am.
send me the attendance.
Okay, ma'am. Yes, ma'am. I've taken the screenshots.
Okay then, right. Send me the screenshots.
Yes, ma'am. I'll send.
Hello, Sandeep.
Yes, ma'am.